Okay guys, welcome back. Again, this is what our lab is going to look like. By the end of the day, we will have finished the orbiter constructor function, and we're going to add a couple of important pieces. The important thing is, while we're doing this lab, you need to be thinking about how you're going to apply this concept to a creature or some creatures in your ecosystem. So we've already had ecosystem kind of phase 1, we'll call this phase 2. But as we go through these different labs through quarter 2, you're going to be adding more and more kinds of properties that we're going to increase behaviors in the different kinds of creatures you have in your ecosystem. Okay, so last time we pretty much finished the setting up the properties in the mover constructor function. We have several properties coming in. We're setting the equal to local variables down here, and then I have this for loop. And the important thing is that we are creating inside, on line 9, we have an array of orbiters. So every mover we saw in that beginning opening screen that were something like 40 or 50 movers, but each mover had its own orbiters. That means that inside the constructor function we put an array, and it's going to be an array of orbiter objects. I didn't create a separate file for the orbiter constructor function. I just put it down at the bottom of the mover constructor function. In any case, once I have my orbiters array declared, then I can go ahead and make this number of orbiters. Notice I pass in n up here as a parameter, and it's coming into my for loop, so I will go to 0, I is less than n, so I'll have n orbiters in this array. And I think in the example I showed you, they ranged from 3 orbiters all the way up to 7. In any case, I take this n down here also because I take math pi times 2, so 2 pi divided by n. And what that means is I'm spacing the orbiters out. So let's say that n is 4, 2 pi divided by 4, that's going to give me pi over 2, or 90 degrees. So each of the orbiters will be 90 degrees. In other words, spaced evenly apart. So if I take 2 pi divided by n, that's going to give me an even space, whether I have 3 or 4 or 5. And then I have this dot orbital angle is just kind of an offset. So if they're rotating, two guys with 3 orbiters don't look like they're rotating in sync. I just have an initial offset. So they are rotating at the same speed, but they're not in sync with each other. I just put this offset because I think it looks visually a little bit more realistic for a kind of an ecosystem. And then let angle velocity. So on line 13, angle velocity is found by the number of orbs times 0.01. And what that means is the angular velocity is going to increase with the number of orbs. So we could have done the opposite. We could have made the ones with fewer orbs speed up or whatever, but they just have some more variation between the different kinds of orbiters. And then finally I take this orbiters and I push in a new orbiter. Now look carefully at the parameters. We have this, which is a mover object, this mover object. Each of the movers is this, whichever one is calling this code. And then I'm going to pass in these values, 425A. A is the same thing that is coming in right here on line 12. Let A equal that angular sort of offset, and then angular velocity, and that's going to be greater for the more orbs we have, the greater that number will be. And then finally we pass in a color. Okay, I'm going to go ahead and just pop in run, render, update, and check edges because we've seen those before. Okay, so here are the other methods in the mover. The only difference in run is I'm going to go ahead in the run, I'm going to call update, check edges, and render just like I have in the past, but I'm also going to run through the for loop and look at each of the orbiter objects, and for each orbiter object, I'm just shortening the code here, by the way. So instead of saying this dot orbiters I dot update, I just changed it to orb. And so remember what these things is. What is this? I'm in the mover class, so this is a mover. Mover has an array. Orbiters is an array that's inside the mover object, and to get to the particular orbiter in slot I just take out. So this whole thing is an orbiter, and so let orb equal that. Orb is the orbiter in slot I of the orbiters array. So orb.update and then orb.render, I'm calling those two functions. Render, I'm not rendering the orbs up here. I'm just rendering the mover. So mover is just like we've seen before. There's an arc. So it's got a line width, it's got stroke style, fill style, line width, and arc. And so that's pretty simple. I'm just rendering a mover. And then finally I am updating it. I'm just adding acceleration to velocity. I'm adding velocity to location, just like before, no big changes there. And then I have check edges. So all of those things we've seen in our other labs, so there's nothing new there. The new part is down here in Orbiter. I need to make properties that are going to match what I'm sending in. And so I think what I'll do here is I'm going to pull this guy off to the side a bit. And as I make new orbiters, let's go ahead and put in game over here. And let's see, where am I? No, not game. I want to see mover over here. So let me put in mover. Okay, and so this is going to allow me to see what I am passing in when I'm making an orbiter. So orbiters are going to take in all of these values here on line 14. So it says new orbiter. I'm going to push in this, and then 4, and then 25. Let's see. If I remember correctly, 4 is the diameter of each individual orbiter, and 25 is the distance from the center of the mover. So the center of the mover and the center of the orbiter will be 25 pixels apart. And so I think I named these something like orbiter radius is 4 and orbit radius is 25. And then I have A is the angular offset, and then angular velocity, and then the color. So let me go ahead and pop those in over here. When I make my new orbiter, that's going to come in right here starting on line 63. So I'm going to plop in my parameters right here. So now I just have to go ahead and set these guys up. I'm going to say this dot mover, and so now these are local properties that are going to be basically references to other things. So for instance, when I pass in this, when I'm making a new orbiter, so let's just pull this over just a little bit. So I'm passing in this. This is in the mover class. So this is a mover object. Whichever mover is using this code is this. So because it's a mover object, it's basically a reference to the mover object, and I can pass it in. So now inside the orbiter knows which mover it is orbiting around. And the important thing is that's important because I need that loc in the particular mover to use as a sort of an anchor point for when I draw the orbiter. Every orbiter is going to be orbiting around a particular mover. So I need that information. Remember, this guy was 4 and this guy was 25. So let me just go ahead and plop these guys in. So here's the rest. I've got this dot mover as before. I've got radius. I've got orbiter radius. So that is the radius of the orbiter, which is 4. That's the diameter of the little orbiter itself. But then I have orbit radius, and orbit radius is going to be... Okay, I'm using that on line 66. If you look, I'm passing in the orbit radius. What I'm going to do is I'm going to have a rotator function, and the rotator function is going to be a JS vector, but then I'm going to set its magnitude, and its magnitude is going to be orbit radius. And so what that means is whatever the radius is, in this case 25, that will be the magnitude of the vector, and then I change its direction with that offset angle that I got randomly, so they're not in sync. And then I'm going to use angular velocity down on 71. I just make a local property, this dot angular velocity. And to make my location vector for this orbiter, I'm going to go ahead and say add get new. So let me draw what's going on here in my drawing tablet. Okay, so here is my canvas, and we know that the origin is up in the upper left-hand corner. That has coordinates 0, 0. And when I draw a mover, we'll call that the mover, what's going to happen is that there is going to be a vector from, let's see, the location vector. So if I want to draw the location vector, let's say in red, the location vector goes from the point 0, 0 to the center, and so that is, if this, whatever mover this is, this guy is represented by this dot loc. So let's say this dot loc in red. Now I want to create an orbiter. So I will simply place the orbiter some distance away, whatever the radius is, some distance away. So here is my orbiter, and I will draw that with a blue vector. And so this vector we could think of, first of all, I'm going to move it a certain distance away from the center. And so that distance is going to be the orbiter radius. Sorry, the orbit radius. The orbit radius is how far away it is from this dot loc, the mover's location. So orbit radius, and I think we set that equal to 25. Okay, so that. Now, if I want to find out what its location is, I simply add those two vectors together. I get a brand new vector, and we've written a function to do this. And so the sum of two vectors, if I have a vector head to tail, so this one's going head to tail, the sum of two vectors is going to be this guy, and so that's going to be the location. And so what I need to do is find out the blue vector and the green vector, and the code to do that looks like this. Okay, so this is the code that we're going to look at back in the Orbital Constructor function. But first, let's just think about what this is doing. The blue vector is the rotator. So that's just a new JS vector. And all I want to do is set its angle and its orbit radius. So the orbit radius we said was 25. So we just take the rotator. We set its magnitude to 25. We set the direction to whatever angle is. And that's the blue. And then to get the green, all I'm going to do is add these two together. But remember that when I use the add function in the vector, if I were to say simply this dot loc dot add, and I were to put in the rotator, let's say rotator, I'll just say rot for short, this doesn't work because that's going to change the location of the mover. That's not what I want to do. I want to add these two together and get the green vector, a brand new vector. So just like when we were working with attraction and repulsion, we used subGetNew. Now we're going to use a class method called addGetNew. And so I will set that equal to the location of this vector. So I'm going to say this dot loc. Now I'm inside of the orbiter, so this is an orbiter. So this dot loc is equal to, and I'm going to say JS vector, and I'm going to use that function add get new, and add get new is going to take in the sum of these two vectors, the blue vector, which is my rotation vector, and the red vector, which is the location of the mover. So mover.loc and the rotation vector. When I add those two together, I get the green vector. That is the location of my orbiter. Okay, so finally I just want to make you draw your attention to line 70. In line 70, I'm getting this dot loc. This is inside the orbiter. So when I'm inside the orbiter, this is the orbiter, whichever orbiter happens to be using this code. So this dot loc, and I find its location by taking this dot mover dot loc, which in our example was the red vector. I'm taking this dot rotator, which in our example was the blue vector. I'm adding those together, and now the location of the orbiter is going to be the green vector, the sum of this dot mover dot loc and this dot rotator. Last thing I want to say is that I'm taking this guy angular velocity, and just to finish this off, I want to mention that angular velocity is what we are calling how far the blue guy is going to be moving in any given frame. So let's just not even use the word frame. Let's just say over a period of time, this guy is going to move. And so let's go ahead and draw another circle here. This angle that it's moving, that is my angular velocity. How fast? If I increase my angular velocity, it's going to be spinning more quickly. If I decrease my angular velocity, it will be decreasing less quickly. And so let's just take one last little look at this in the update function. So now to update this, I need a couple of things. In my update function, I'm going to add a couple lines of code down here, and what I want to do is I want to say this dot rotator, which is a vector, dot rotate. So in the JS vector class, we have a rotate method, and I'm just going to add whatever the angular velocity is. The larger the angular velocity, the more, or the bigger the angle of rotation, so it will appear to be rotating more quickly. And then finally, I want to, on line 80, just create a brand new line, a brand new location vector. So I'm just going to simply say exactly the same thing I did on line 70. Line 80 and line 70 are doing the same thing. They're creating a brand new vector at location where I get these, I simply add what was in our example, our red vector and our blue vector, and I get a new green vector. So that's what's taking place there. And now let's finish this off by looking at the render, and the render is just going to simply be rendering a circle, and that's for the orbiter itself, and then I drew a line from the mover to the orbiter, and so that's just taking move to and line to. So move to is going to be going to the mover.loc.x and mover.loc.y, and then it's going to go line to this, which is the orbiter.loc.x, and this.loc.y. So the location vector of the mover to the location vector of this orbiter, and that's it. So go ahead and get this lab done, and the next thing we're going to talk about is how to add features to your creatures in your ecosystem. That's it for tonight. Bye.